Unit exercise 3. Question number 1. Solve 1 by 3 into x plus y minus 5 equal to y minus z equal to 2x minus 11 equal to 9 minus of x plus 2z. Now let us take first and second. First and second. Multiply by 3 both sides. So x plus y minus 5 equal to 3y minus 3z. So we have avoided the fraction 1 by 3. That is x minus 2y plus 3z equal to 5. Equation 1. Then I have taken second and third. Second and third. That is y minus z is equal to 2x minus 11. That is 2x minus y plus z equal to 11. Second equation. Then I have taken third and fourth. You can as well take second and fourth. Now I have taken the third equation and the fourth equation. That is 2x minus 11 equal to 9 minus x minus 2z. That is 3x plus 2z is equal to 29 plus 11. Third equation. Thus we have three equations. I have taken first equation, second equation, then second and third and fourth. You can take second and third, second and fourth like that. Anyway, we have created three equations from the given equations. We have to solve. We have three linear equations in three variables. We can solve. Let us eliminate y between 1 and 2. Here we have minus y. So multiply the second equation by 2. X minus 2y plus 3z equal to 5. First equation as it is. Multiply the second equation by 2. That is 4x minus 2y plus 2z equal to 22. Subtract. Minus 3x plus z equal to minus 17. Changing sign throughout. 3x minus z equal to plus 17. Equation 4. Now we have equation 3. 3x plus 2z equal to 20. 3x plus 2z equal to 20. Equation 3. We have the fourth equation that we have formed. 3x minus z equal to 17. On subtraction, 3z equal to 3. That is z equal to 1. We have the fourth equation. 3x minus z equal to 17. Put z equal to 1. So 3x minus 1 equal to 17. That is 3x equal to 18. X equal to 6. So we have found out x and z. Now first equation, x minus 2y plus 3z equal to 5. Or you can as well take the second equation. You have to get the value of x. Now the first equation is taken. X minus 2y plus 3z equal to 5. That is 6 minus 2y plus 3 equal to 5. We have already got the values of x and z. We have to get the value of y. On substituting the values of x and z, we get 9 minus 2y equal to 5. That is minus 2y equal to 5 minus 9. That is minus 2y equal to minus 4, y equal to 2. So the values of x, y, z are x equal to 6, y equal to 2, z equal to 1. The given equations have a unique solution. That is x equal to 6, y equal to 2, z equal to 1. Unit exercise 3, sum number 2. 150 students are admitted to a school. 150 students, total number of students. They are distributed over 3 sections, A, B and C. If 6 students are shifted from section A to section C, their sections, that is A section and C section, will have equal number of students. If 4 times of students of section C exceeds the number of students of section A by the number of students in section B, find the number of students in the 3 sections. So let us assume that the number of students in the sections A, B, C to be X, Y, Z respectively. So X plus Y plus Z, total number of students admitted to the school is 150, one equation. Then the second statement, if 6 students are shifted from section A, how many students are in section A? X. 6 students are shifted. So X minus 6. They are shifted from section A to section C. How many students are in section C? Z. The 6 students go from A to C. So the number of students in C become Z plus 6. But it is given the sections will have, the section means the sections A and C will have equal number of students. So X minus 6 equal to Z plus 6. 6 students are shifted from section A to section B. Then the number of students in A and C will be X minus 6 and Z plus 6. It is given A and C will have same number of students. So X minus 6 equal to Z plus 6. In other words, X minus Z equal to 6 plus 6, that is 12. Equation 2. Then third statement. If 4 times of students of section C, that is 4Z, 4 times the students of section C exceeds the number of students of section A by the number of students in section B. So 4Z exceeds X by Y, that is 4Z minus X equal to Y. 4 times the number of students in section C exceeds now the number of students in section A, that is 4Z minus X by Y. By Y means by the number of students in B. So 4Z minus X equal to Y. Simplify. X taken to the other side. X plus Y minus 4Z equal to 0. Thus we have 3 equations. X plus Y plus Z equal to 150. X minus Z equal to 12. And X plus Y minus 4Z equal to 0. First equation minus third equation. X will get cancelled. Y will get cancelled. Z plus 4Z, that is 5Z equal to 150, because 150 minus Z. That means Z equal to 150 by 5, that is 30. So we have the value of Z. The second equation we have X minus Z equal to 12. In that we have Z value. X minus 30 equal to 12. That is X equal to 12 plus 30, that is 42. So Z is known, X is known. We have to find the value of Y. We have the first equation, X plus Y plus Z equal to 150. So 42 plus Y plus 30 equal to 150. That is 72 plus Y equal to 150. That is Y equal to 150 minus 72. That is 78. So X equal to 42, Y equal to 78 and Z equal to 30. The number of students in the sections A, B and C are 42, 78 and 30 respectively. We have done the problem. Unit exercise 3, sum number 3. In a 3-digit number, when the tens and hundreds digit are interchanged, tens and hundreds digits interchange, the number is 54 more than 3 times the original number. Let us take the 3-digit number to be 100x plus 10y plus z. So unit digit is z, tens digit y, hundreds digit is x. then the tens and hundreds digit are interchanged. Tens and hundreds are interchanged. So it becomes 100y and 10x. Y comes here, x goes there. So 100y plus 10x, that z remains as it is, plus z is equal to 54 more than 3 times the original number. 54 more, that is 54 plus 3 times the original number. So 3 into 100x plus 10y plus z. So first take a statement we have written in the form of an equation. Simplified. 100y plus 10x plus z is equal to 54 plus 300x plus 30y plus 3z. That is minus 290x minus 290x plus 70y minus 2z equal to 54. We can divide throughout by minus 2. So 145x minus 35y, we are dividing by minus 2, plus z equal to minus 27. Equation 1. Then take up the second statement. If 198 is added to the number is 100x plus 10y plus z. 100x plus 10y plus z. If 198 is added to the number, then the digits get reversed. The digits were x, y, z. It will become z, y, x. So z, y, x. The digits get reversed. It was originally x, y, z. Now it will become z, y, x. Reverse order. So 100z plus 10y plus x. So the second statement has been written in the form of an equation. 100x plus 10y plus z plus 198 equal to 100z plus 10y plus x. That is 99x minus 99z equal to minus 198. The numbers are divisible by 3, so divide throughout by 3. 33x minus 33z equal to minus 66. We can divide throughout by 33. So x minus z equal to minus 2. Equation 2. Now let us take up the third statement. The tens digit exceeds the hundreds digit by twice as that of the tens digit exceeds the unit digit. The tens digit exceeds the hundreds digit by what amount? By twice as that of the tens digit exceeds the unit digit. So it is given y minus x, y minus x. The tens digit exceeds the hundreds digit, that is y minus x. Y minus x is twice as that of the tens digit, that is y minus z, exceeds the unit digit. So y minus x equal to 2 into y minus z is the equation you get from the last statement. That can be simplified. Y minus x equal to 2y minus 2z. That is minus x minus y plus 2z equal to 0. That is x plus y minus 2z equal to 0. Third equation. Thus we have three equations. 145x minus 35y plus z equal to minus 27. X minus z equal to minus 2. X plus y minus 2z equal to 0. So we have to solve for x, y and z. Now first equation plus second equation, that z will get cancelled. 146x minus 35y is equal to minus 29. That we call fourth equation. Fourth equation is got by eliminating z between 1 and 2. Now let us eliminate z between 2 and 3. Second equation, third equation. Now first equation will have to be multiplied by 2. So 2x minus 2z equal to minus 4. And the third equation, x plus y minus 2z equal to 0. Subtracting 2x minus x minus 2z plus 2z get cancelled. When we subtract this, plus y will become minus y. So x minus y equal to minus 4. X minus y equal to minus 4, because minus 4 minus 0 minus 4. Now 146x minus 35y equal to minus 29. That is the fourth equation that we have got. 146x minus 35y equal to minus 29. We have got the fifth equation, x minus y equal to minus 4. The two equations have the variables x and y. Two equations, two variables. We can solve. Now the first equation I have taken as it is. The second equation I have multiplied by 35. So 35x minus 35y equal to 35 into minus 4. That is minus 140. Now on subtraction, 146x minus 35x, that is 111x. Y get cancelled. Minus 29 plus 140, that is 111. So x equal to 111 divided by 111, that is x equal to 1. We have the fifth equation, x minus y equal to minus 4. We know x value, substitute 1 minus y equal to minus 4, that is 1 plus 4 equal to plus y, that is y equal to 5. X equal to 1, y equal to 5. I have taken the third equation. We have to get the value of z. X plus y minus 2z equal to 0. That is 1 plus 5 minus 2z equal to 0. That is 6 minus 2z equal to 0. That is 2z equal to 6. That is z equal to 3. So x equal to 1, y equal to 2, z equal to 3. We want the original number. We want the number with which we started. That is the number 100x plus 10y plus z, and that is found to be 100 into 1 plus 10 into 5 plus 3, that is 153. That is the answer. That finishes the find the LCM of question number 4. Unit exercise 3, question number 4. Find the LCM of xy into k square plus 1 plus k into x square plus y square and xy into k square minus 1 plus k into x square minus y square. Take the first one, xy into k square plus 1 plus k into x square plus y square. This is k squared xy plus xy plus kx square plus ky square. That is kx square plus k square plus 1 xy. These two terms, xy is taken common, so k square plus 1 xy plus ky square. Or we can say this way, kx square plus ky square and this term, that is k square plus 1 into xy. Now we can factorize this. First number, last number is k square, so the product must be k square and the sum must be k square plus 1. The two numbers are k squared and 1. The product is k square and the sum is k square plus 1. The equation of x squared is k, so divide both k squared and 1 by k. K squared by k, that is k by 1 and 1 by k. Start with the denominator, use the letters x and y. So this is x plus ky into kx plus y. So these are the factors. Then the other one, xy into k squared minus 1 plus k into x squared minus y squared. That is k squared xy minus xy plus kx squared minus ky squared. That is kx squared plus, for these two terms we can take xy common, that is k squared minus 1 into xy minus ky squared. first and last, k into minus k squared. So the product must be minus k squared and sum must be k squared minus 1. The numbers are k squared and minus 1. The equation of x squared is k, so divide both k squared and minus 1 by k. K squared by k is k by 1. This is minus 1 by k. Start with the denominator. Use x and y. So x plus ky into kx minus y. So we have first expression factorized, the second expression factorized. Then we can find the LCM as x plus ky into kx plus y into kx minus y. The last two terms a plus b to a minus b. So k squared x squared minus y squared. LCM is x plus ky into k squared x squared minus y squared. A little. We can also do the problem this way. xy into k square plus 1 plus k into x square plus y square. That is kx squared first term plus k square plus 1 into xy or xy into k square plus 1. This is constant, this is variable. So xy into k square plus 1 plus ky square. Now multiply this kx squared plus k squared xy plus xy plus ky squared. Take kx common for the first two terms and y common for the next two terms. So kx into x plus ky. Y taken common, x plus ky. Now x plus ky is taken common. So x plus ky into kx plus y. We have factorized the first expression. Then taking up the second expression, xy into k squared minus 1 plus k into x squared minus y squared. That is kx squared plus k squared xy, here xy into k squared minus 1 plus minus ky squared. Now multiply kx squared minus plus k squared xy minus xy minus ky squared. First two terms kx common, so kx into x plus ky. Last two terms minus y common, so minus y into x plus ky. X plus ky is now common, x plus ky, x plus ky. Then x plus ky is taken common, x plus ky into kx minus y. So we have factorized the first and the second expressions. So LCM equal to, as usual, x plus ky into kx plus y into kx minus y. That's all. The two brackets may be multiplied, k squared x squared minus y squared. So there ends the problem. Unit exercise 3, sum number 5. We have to find the GCD of 3 polynomials using division algorithm. Now the first polynomial in x is a 4th degree, second one polynomial of 3rd degree. Let us divide the 4th degree polynomial by the 3rd degree polynomial. 2x power 4 divided by x cube is 2x. So 2x is the first term in the quotient. 2x into x cube, 2x power 4. 2x into 3x squared, 6x cube. 2x into 3x, 6x squared. 2x into 1, 2x. Subtract. 2x power 4 minus 2x power 4, 0. They get cancelled. 13x cubed minus 6x cubed. That is 7x cubed. 27x squared minus 6x squared plus 21x squared. 23x minus 2x plus 21x. Bring down that last term 7 here. Now 7x cubed when divided by x cubed gives 7. So 7 is the next term in the quotient. Multiply by 7. 7x cubed plus 21x square plus 21x plus 7. Subtract. The remainder is 0. So the GCD of first and second polynomial is x cubed plus 3 3x squared plus 3x plus 1, the divisor here. For the first and the second, we have got on division, the remainder is found to be 0. So the divisor x cubed plus 3x squared plus 3x plus 1 is the GCD of the first two polynomials. Now let us take up the GCD of the first and second polynomial x cubed plus 3x squared plus 3x plus 1 with the given third polynomial. The third polynomial is of degree 2. So let us divide the GCD of the first two polynomials that we have got, x cubed plus 3x squared plus 3x plus 1. First ரெண்டுக்கும் GCD கண்டுபிடிச்சிருக்கோம். அதை third polynomial divide பண்ணி அது ரெண்டுக்கும் நாம GCD கண்டுபிடிக்க போறோம். That will be the final answer. So x cubed plus 3x squared plus 3x plus 1 is the GCD of first two polynomials. So அந்த first two polynomials உடைய GCD க்கும் the third polynomial க்கும் நம்ம GCD கண்டுபிடிச்சா போதும். X cubed when divided by x squared gives x, multiplied by x, x cubed plus 2x squared plus x, subtract x square plus 2x, bring down that 1 plus 1, x square divided by x squared is 1, so plus 1, 1 into x square plus 2x plus 1, x square plus 2x plus 1, remainder is 0. So the final divisor here, x square plus 2x plus 1 is the GCD of the given polynomials. The given three polynomials will have x square plus 2x plus 1 as their GCD. So we have finished the sum. Unit exercise 3. Question number 6. First subdivision. Reduce to lowest form. X to the power of 3a minus 8 whole divided by x to the power of 2a plus 2x power a plus 4. Now let us take the numerator and try to factorize it. X to the power of 3a minus 8 is x to the power of a whole cube minus 2 cube. Now this is of the form a cubed minus b cubed. The factorization formula a minus b into a squared plus ab plus b squared. That is x to the power of a minus 2 into x to the power of a whole squared plus x to the power of a into 2 plus 2 squared. A cubed minus b cubed equal to a minus b into a squared plus ab plus b squared. That is x to the power of a minus 2 into x to the power of 2a plus 2 into x to the power of a plus 4. So the given fraction becomes x to the power of a minus 2 into x to the power of 2a plus 2x to the power of a plus 4 whole divided by x to the power of 2a plus 2 into x to the power of a plus 4. Now these two factors get cancelled. We are left with x to the power of a minus 2, that is the reduced form. So we have the fraction reduced to the simplest form. So the problem is done. Unit exercise 3, sum number 6, second subdivision. We have to reduce to the lowest form. 10x cubed minus 25x squared plus 4x minus 10 upon minus 4 minus 10x squared. Take the numerator 10x cubed minus 25x squared plus 4x minus 10. For the first two terms we can take 5x squared common. So 5x squared into 2x minus 5. For the next two terms we can take 2 common. So 2 into 2x minus 5. 2x minus 5, 2x minus 5 common. So we can take it out. So 2x minus 5 into 5x squared plus 2. Numerator over. Take up denominator. Minus 4 minus 10x squared. We can take minus 2 common. So minus 2 into 2 plus 5x squared. This 2 plus 5x squared occurs there also. So let us take up the whole fraction. The given fraction equal to numerator numerator is 2x minus 5 into 5x squared plus 2. Denominator is minus 2 into 2 plus 5x squared. 2 plus 5x squared, 2 plus 5x squared, they get cancelled. We get 2x minus 5 whole divided by minus 2. If you want, you can divide term by term. 2x by minus 2, that gives minus x. Minus minus becomes plus 5 by 2. That's the answer. That's a reduced form of the given fraction. We have done the problem. Unit exercise 3, sum number 7. Simplify 1 by p plus 1 by q plus r upon 1 by p minus 1 by q plus r into 1 plus q squared plus r squared minus p squared divided by 2qr. Now simplify the numerator, simplify the denominator. For numerator, LCM is p into q plus r. So we will be getting q plus r plus p. For the denominator, p into q plus r LCM. So q plus r minus p into LCM 2qr. So 2qr plus q squared plus r squared minus p squared. Now this p into q plus r will get cancelled, because if you invert the denominator, the two will get cancelled. Denominator of numerator and denominator of the denominator are same, they will get cancelled. So we will be left with q plus r plus p divided by q plus r minus p into the first three terms, nothing but q plus r whole square. Q squared plus r squared plus 2qr is nothing but q plus r whole square minus p squared divided by 2qr. This is as it is. This is something like a squared minus b squared. That's equal to a plus b into a minus b. That is q plus r plus p into q plus r minus p divided by 2qr. Q plus r minus p, q plus r minus p, they will get cancelled because into. And q plus r plus p into q plus r plus p is q plus r p whole square. Q plus r plus p whole square divided by 2qr. That's the simplest form. The textbook answer is not correct for the problem. Unit test 3, sum number 8. Arul, Ravi and Ram, 3 persons working together, can clean a store in 6 hours. If they work together, they can clean in 6 hours. Working alone, when Ravi takes twice as long to clean the store as Arul does. Ram needs 3 times as long as Arul does. How long would it take each if they are working alone? So Arul, Ravi, Ram. We have to find how long it would take if each of them work alone. Let us assume that Arul, Ravi, Ram take x, y, z hours to clean all alone. So Arul takes x hours, Ravi takes y hours, and Ram takes z hours to clean the store if they are working separately. So Arul takes x hours. So in 1 hour he will be doing 1 by x work. Similarly for Ravi, in 1 hour 1 by y work, and Ram 1 by z work. So 1 by x plus 1 by y plus 1 by z is the amount of work done by the 3 persons together in 1 hour. It is given in the problem, they clean in 6 hours. So in 1 hour they will be doing 1 by 6 work. So 1 by x plus 1 by y plus 1 by z equal to 1 by 6. Equation 1. Arul cleans in x hours, Ravi cleans in y hours, Ram cleans in z hours. All the 3 together clean in 6 hours. All the three does 1/6th part of the work in 1 hour. Work done by Arul in 1 hour, 1/x. Work done by Ravi in 1 hour, 1/y. Work done by Ram in 1 hour, 1/z. So work done by all the three in 1 hour is 1/x plus 1/y plus 1/z. That's equal to 1/6, because 1/6 is the work done by all the three together. That's equation 1. Then second statement, working alone, Ravi takes Ravi, that is y. Y equal to twice as long to clean as Arul does. Arul is x, so y equal to 2x, because Ravi is y. So Ravi takes twice as long to clean as Arul does. So y equal to 2x, equation 2. Then third statement, Ram needs 3 times as long as Arul does. Ram, that is z, is equal to 3 times x. That is the equation for the third statement. So the three statements are converted into 3 equations. We have to get the values of x, y, z. Now from the second equation, y equal to 2x, 1/y is 1/2x. 1/y is 1/2x. From the third equation, 1/z equal to 1/3x. Using the values of y, 1/y and 1/z, in the first equation, 1/x as it is 1/x plus 1/y is 1/2x plus 1/z is 1/3x equal to 1/6. So successfully we have got an equation which contains only one variable. Now take LCM. 6x is the LCM, and we get 6 plus 3 plus 2. 6 plus 3 plus 2 equal to 1/6. That is 11/6x equal to 1/6. That is 11/x equal to 1. Multiplying both sides by 6. 11/x equal to 1. That is x equal to 11. Once we know x means, we can write down the other values. Y equal to 2x. So y equal to 2 into x is 11. That is 22. Z is 3x. That is z equal to 3 into 11. That is 33. So the values of x, y, z are 11, 22, 33. They take 11 hours, 22 hours and 33 hours if they work all alone. That's all the problem. Unit exercise 3, sum number 9. Find the square root of a 4th degree polynomial in x is given. So write the 4th degree polynomial here. 289x power 4. Square root of 289 is 17. Square root of x power 4 is x squared. 17x squared. Here also write 17x squared. Multiply 17x squared into 17x squared, getting 289x power 4. Subtract 289x power 4 minus 289x power 4 get cancelled. So bring two terms down. Minus 612x cube plus 970x squared. The two terms. Now 17x square multiplied by 2, 34x square. Divide 612x cube by 34x square, getting minus 18x. Multiply by minus 18x. That minus 18x must be written here also. Multiply by minus 18x. Minus 18x into 34x squared minus 612x cube. Minus 18x into minus 18x, 324x squared. Subtract 646x squared. Bring down the remaining two terms. Minus 684x plus 361. Multiply 17x squared minus 18x by 2, getting 34x square minus 36x. 646x square divided by 34x square gives 19. 646x square divided by 34x square gives 19. That's the last part of the square root, last number. Multiply by 19, 34x squared minus 36x plus 19, getting 646x squared minus 684x plus 361. Subtract, we get 0. And the square root is 17x squared minus 18x plus 19. Unit exercise 3, sum number 10. Solve square root of y plus 1 plus square root of 2y minus 5 equal to 3. Now there are two square roots. We have to isolate a square root. When an isolated square root is squared, that square root will be removed. Let me repeat. When we square an isolated square root, that isolated square root will be removed. There are two square roots. Let us isolate square root of y plus 1. So square root of y plus 1 equal to 3 minus square root of 2y minus 5. There were two square roots side by side. I have isolated square root of y plus 1. Now on the left hand side we have got only one square root. Squaring both sides, square root of y plus 1 whole squared is y plus 1. That square root is removed. So we are able to remove that square root by isolating square root of y plus 1 and squaring. Now the right hand side has to be squared. 3 minus square root of 2y minus 5 whole square. Y plus 1 equal to square it. Square 9 square 2y minus 5. 2 times first and second. That is minus 2 into 3 into square root of 2y minus 5. That is y plus 1 equal to 2y plus 4 minus 6 into square root of 2y minus 5. Originally there were two square roots. We are successful in getting rid of one of the square roots. Now we have an equation wherein we have got only one square root. Even this square root is to be removed. Even this square root is to be removed. Whenever a square root is to be removed, that must be first of all isolated. So isolate this radical. That is minus 6 into square root of 2y minus 5 must be isolated. Must be isolated means there should be no other term except that term by the side of it. So y plus 1 minus 2y minus 4 is equal to minus 6 into root of 2y minus 5. That is minus y minus 3 equal to minus 6 into square root of 2y minus 5. If you want, you can change the sign throughout. That is y plus 3 equal to 6 into square root of 2y minus 5. Now this is all alone. There can be 6 in the form of into, but there is no plus or minus in between. So this has been isolated. Squaring both sides, y plus 3 whole squared equal to square of 6 is 36, square of 2y minus 5 is simply 2y minus 5. A plus b whole squared expansion, y square plus 6y plus 9 equal to 72y minus 180. That is y square plus 6y minus 72y plus 9 plus 180 equal to 0. That is y square minus 66y plus 189 equal to 0. Let us solve this quadratic equation y by formula method. That is minus b plus r minus square root of b squared minus 4ac whole divided by 2a. The middle term is sign of 66 plus or minus நாம இங்க என்ன எழுதிருக்கோமோ அதை ஸ்கொயர் பண்ணி போகணும். 66க்கு ஸ்கொயர் 4356 minus 4 times first number 1 into last number 189 whole divided by 2 times the first number 1. That is y equal to 66 plus or minus square root of 4356 minus 4 times 189 is 756 whole divided by 2. That is 66 plus or minus square root of 3600 whole divided by 2. That is 66 plus or minus 60 whole divided by 2. So 66 plus 60 by 2, 66 minus 60 by 2. That is 126 by 2 and 6 by 2. That is 63, 3. So we have got two values of y. Y equal to 63, y equal to 3. Whenever a solution is obtained by squaring, we have to check up for extraneous roots. Some values which are not at all the solution for the given equation have entered into our final answer. So we have to check up. We have to see whether 63 satisfies the given equation. If it satisfies, then it is a solution. Otherwise, it is not a solution. Now, for 63, what is the given equation? Root y plus 1 plus root 2y minus y equal to 3. Put y equal to 63. So root 63 plus 1 plus root 2 into y, 2 into 63, 126 minus 5. That's equal to 3. Root 64 plus root 121 equal to 3. That is 8 plus 11 equal to 3. That is 19 equal to 3. We are getting an absurd result. We are getting a wrong result. So y equal to 63 is not a solution of the given equation. Now let us check up 3. Now y equal to 3. Given equation, you substitute y equal to 3. Root of 3 plus 1 plus root of 6 minus y equal to 3. That is root 4 plus root 1 equal to 3. That is 2 plus 1 equal to 3. 3 equal to 3. This is true. So we have got a true result. That means y equal to 3 is a solution of the given equation. So the given equation has got only one solution, namely y equal to 3. If that y equal to 3 also doesn't satisfy, means the given equation has no solution, has no real solution. Therefore y equal to 3 is the only solution. The textbook answer is not correct for the problem. Unit exercise 3, sum number 11. A boat takes 1.6 hours longer to go 36 kilometers up a river than down the river. A boat takes 1.6 hours longer to go 36 kilometers up a river than down the river. To go up, longer time. To go down, smaller time. If the speed of the water current is 4 km per hour, what is the speed of the boat in still water? Let us assume x km per hour to be the speed of the boat in still water. Now, when the boat goes up, its speed will be x minus 4 km per hour. When it goes down, its speed will be x plus 4 km per hour. When it is going against water, the speed of the boat will be x minus 4. Its speed minus the speed of water current. When it goes down, the speed of the boat will be speed of the boat plus water current, speed of water current. Now let us start. Given that the speed of water current is 4 km per hour, therefore time to go up 36 km is distance by speed. Distance is 36 kilometers and the speed is x minus 4. And time to go down 36 km is 36 by x plus 4. Here x minus 4 because going up. the speed will be lesser. Here going down, so the speed will be more. Since x minus 4 is less and x plus 4 is more, denominator less, so the time to go up will be more. X plus 4 is more than x minus 4, so the time to go down will be lesser. It is given boat takes 1.6 hours longer to go 36 kilometers up than down the river. So 36 by x minus 4 minus 36 by x plus 4 equal to 1.6. This is bigger number because denominator is smaller than this. So bigger number minus smaller number. This is time taken to go up. It will be more. This is a time to go down the river. So it will be a smaller number. So 36 by x minus 4 minus 36 by x plus 4 is given to be 1.6. 1.6 hours. To avoid fraction, multiply throughout by x minus 4 into x plus 4. That is 36 into x plus 4. We are multiplying by x minus 4 into x plus 4. So this x minus 4 will get cancelled with this x minus 4. We will be having 36 into x plus 4 minus 36 into x minus 4. We are multiplying by x plus 4 into x minus 4. That x plus 4 will get cancelled. We will get minus 36 into x minus 4 is equal to 1.6 into x minus 4 into x plus 4. 36, 1.6 divisible by 4, divide throughout by 4. 9 into x plus 4 minus 9 into x minus 4 equal to 0.4 into a plus b into a minus b, x square minus 4 square. That is 9x plus 36 minus 9x plus 36 is equal to 0.4 into x squared minus 16. That is 9x get cancelled. 36 total 72 equal to 0.4 x square minus 0.4 into 16, 6.4 minus 6.4. That is 0.4 x squared is equal to 72 plus 6.4. That is 78.4. 0.4 x squared equal to 78.4. So x squared equal to 78.4 divided by 0.4. That is 784 divided by 4. I have removed the decimals both in the numerator and denominator by multiplying numerator and denominator by 10. Now this is equal to 196. X squared equal to 196. So x equal to square root of 196. That's equal to plus or minus 14. That is x equal to 14. We can't admit x equal to minus 14 because x is the speed. X is the speed of the boat. That cannot be negative. So we get x equal to 14 km per hour. The speed of boat in still water is 14 km per hour. We have successfully solved the problem. Working is over. Unit exercise 3, sum number 12. Is it possible to design a rectangular park of perimeter 320 meter and area 4800 square meter? If so, find its length and breadth. Length x meter, breadth y meter, perimeter 320 meter, area 4800 square meter. Perimeter is 2x plus 2y, that's equal to 320, and area length into breadth xy equal to 4800. That is x plus y equal to 320 divided by 2, that is 160. We have two equations, x plus y equal to 160 and xy equal to 4800. Let us eliminate one of the variables. We can eliminate y or x. I have eliminated y. From the first equation, y equal to 160 minus x. Use it in the second equation. That is x into, instead of y, 160 minus x equal to 4800. That is 160x minus x squared equal to 4800. That is x square minus 160x plus 4800 equal to 0. A quadratic equation, let us solve it by formula method. Minus 160, so plus 160, plus or minus square root of square this number, that is 25,600, minus 4 times first number into last number, that is minus 4 into 1 into 4800, that is 19,200 with minus sign there, whole divided by 2 into 1, that is 160 plus or minus, subtract, getting 6,400. Square root of 6,400 is 80. So 160 plus or minus 80 by 2. That is 160 plus 80 by 2 and 160 minus 80 by 2. That is 240 by 2 and 80 by 2. That is 120, 40. Now x, that is length, may be 120 or 40. Now everything is in terms of meters. So x is 120 meter or 40 meter. When x equal to 120, y equal to 160 minus 120, because we have got an equation here, x plus y equal to 160. So when x equal to 120, y equal to 160 minus 120, that is 40. When x equal to 40, y equal to 160 minus 40, that is 120. We get the same rectangle, 120, 40. One side 120, another side 40. Here 40, 120. So the size of the rectangle are 120 and 40. The dimensions of the rectangle are length 120 meter. Since it happens to be a bigger number than 40, I call it as length. Length equal to 120 meter and breadth equal to 40 meter. Yes, it is possible to construct a rectangle whose perimeter is 320 meter and area is 4800 square meter, and its dimensions would be 40 meter and 120 meter. That's all. Unit exercise 2, sum number 13. At t minutes past 2 p.m. At t minutes past 2 p.m. the time needed to 3 p.m. is 3 minutes less than t squared by 4. 3 minutes less than t squared by 4. Find t. So the wording of the problem must be converted into an equation. Let us convert everything in terms of minutes and do the problem. T minutes past 2 p.m. That is after t minutes. After t minutes, what will be the time? Now 2 p.m. That is 2 into 60 minutes. After t minutes, 2 into 60 plus t. So many minutes. Now t minutes past 2 p.m. the time required, time needed to 3 p.m. What is 3 p.m.? 3 into 60 minutes. The time to reach 3 into 60 is 3 minutes less than t squared by 4. So 3 into 60 minus 2 into 60 plus t. That is this time minus this time is the time required to reach 3 p.m. t minutes after 2 p.m. is 3 minutes less than t squared by 4. That is t squared by 4 minus 3. Now let me repeat. Now 2 p.m. After t minutes, 2 into 60 plus t. So 2 into 60 plus t is the time after t minutes. So after t minutes, that is t minutes past 2 p.m. the time required to reach 3 p.m. that is 3 into 60 is 3 minutes less than t squared by 4. What's the time required to reach 3 into 60? The time is 2 into 60 plus t. The time to be reached 3 into 60. So what's the time required? 3 into 60 minus 2 into 60 plus t. That time required, of course in minutes, is 3 minutes less than t squared by 4. So this is the equation. This is an equation in terms of t. So we can get the value of t by solution. That is 120 minus 120 minus 180 minus 120 minus t. 3 into 60. 180 minus 120 minus t equal to t square by 4 minus 3. That is 60 minus t equal to t squared by 4 minus 3. We can multiply throughout by 4, getting 252 minus 40 equal to t squared. This is 60, this is minus 3. Minus 3 brought this side, plus 3. So 63 minus t equal to t squared by 4. Multiply throughout by 4. 252 minus 40 equal to t squared. Rearrange. T square plus 40 minus 252 equal to 0. Solve by formula method. So t equal to நடுவில் இருக்கிற நம்பரை சைனை மாற்றி போடணும். இங்கே போட்ட நம்பருக்கு ஸ்கொயர் போடணும். minus 4 times first number and last number. Last numberல ஒரு மைனஸ் வரதுனால இது பிளஸ் ஆயிடும். 4 times 252 is 1008. Total 1024. அதுக்கு ரூட் எடுத்தா 32. So 2 times a, that is 2 times first number. So minus b plus or minus square root of b squared minus 4ac whole divided by 2e. Minus 4 plus or minus square root of 1024 is 32 whole divided by 2. That is minus 4 plus 32 by 2 minus 4 minus 32 by 2. Then time cannot be negative, so we ignore it. It is inadmissible. So the only value of t is 28 by 2, that's equal to 14 minutes. This quadratic equation has got two roots, of which one root is to be rejected for this particular problem. So we get t equal to 14 minutes. That is the answer. Find t. The value of t is 14 minutes. Unit exercise 3, question number 14. The number of seats in a row is equal to the total number of rows in a hall. So the number of seats in each row is equal to the total number of rows in the hall. The total number of seats in the hall will increase by 375 if the number of rows is doubled and the number of seats in each row is reduced by 5. Find the number of rows in the hall at the beginning. Let us assume that at the beginning the number of rows is x. Number of rows is x. There are x rows. So the number of seats in each row is x, because it is given the number of seats in a row equal to number of rows. How many seats in a row? X. How many rows? X. Number of seats in a row equal to number of rows. Number of seats in each row? X. Number of rows? X. So in each row there are x seats and there are x rows. So what is the number of seats? X into x. There are x rows. Each row contains x seats. So the number of seats in the hall is x into x, that is x squared. We assume that the number of rows is x. That means the number of seats in each row is x as per the problem, as per the first statement of the problem. So the number of seats at the beginning is x squared. Now when the number of rows is doubled, that is 2x, and the number of seats in each row is reduced by 5. So x minus 5. 2x is the number of rows is doubled. So the new number of rows is 2x. And the number of seats in each row is reduced by 5. So number of seats in each row is now x minus 5. Number of rows doubled and number of seats in each row is reduced by 5. Then what will be the number of seats now? 2x into x minus 5. That is given to be equal to x square plus 375 because the number of seats increases by 375. Originally there were x square seats that has increased by 375. So 2x into x minus 5 equal to x square plus 375 as per the second statement of the problem. This is a quadratic equation we can solve. Multiply 2x square minus 10x equal to x square plus 375. That is x square, 2x squared minus x squared minus 10x minus 375 equal to 0. Solve by formula method. 10 plus or minus square root of 100 minus 4 times first number last number gives plus 1500 whole divided by 2 into 1. That is 10 plus or minus 1600 whole divided by 2. That is 10 plus or minus 40 by 2. That is 10 plus 40 by 2, 10 minus 40 by 2. That is 50 by 2, comma, minus 30 by 2. Minus 30 by 2 rejected because it is a negative number. Number of rows x cannot be negative. So we get x equal to 25. X is the number of rows. So the number of rows in the hall at the beginning is 25. So originally there were 25 rows and each row had 25 seats. The number of rows in the hall at the beginning were 25. Number of rows 25 originally, and each row had 25 seats. We are not interested about the number of seats. We are interested only the number of rows at the beginning. The number of rows at the beginning was 25. That ends the problem. Unit exercise 3, sum number 15. If alpha comma beta are the roots of the quadratic equation x squared minus 2x plus 3 equal to 0, subdivision 1, find the equation whose roots are alpha plus 2 comma beta plus 2. So we have to form that equation whose roots are alpha plus 2 comma beta plus 2. That is, we have to form the equation whose roots, each of the roots increased by 2. Okay. Alpha beta are the roots of the equation x squared minus 2x plus 3 equal to 0. Therefore alpha plus beta equal to minus of minus 2 by 1, that is 2. Alpha beta equal to c by a, that is 3 by 1, that's equal to 3. So alpha plus beta equal to 2, alpha beta equal to 3. What are the roots of the equation that is to be formed? Alpha plus 2 and beta plus 2. Sum alpha plus 2 plus beta plus 2. That is alpha plus beta plus 4. That is 2 plus 4 because alpha plus beta is 2. So S equal to 6. And product alpha plus 2 into beta plus 2. That is alpha beta plus 2 alpha plus 2 beta plus 4. We know alpha beta, we can take 2 common here. So alpha beta plus 2 into alpha plus beta plus 4. That is 3 value of alpha beta plus 2 into alpha plus beta 2 plus 4. That is 3 plus 4 plus 4, that is 11. We have S and P. The required equation is x squared minus 8x plus b equal to 0. That is x squared minus 6x. The value of S is 6. So x squared minus 6x plus product is 11 equal to 0. That is the required equation. Unit exercise 3, sum number 15, second subdivision. If alpha beta are the roots of the equation x squared minus 2x plus 3 equal to 0, form the equation whose roots are alpha minus 1 by alpha plus 1, beta minus 1 by beta plus 1. Alpha beta are the roots of the equation x squared minus 2x plus 3 equal to 0. So alpha plus beta equal to 2. Minus of minus 2 by 1, that is 2. and alpha beta equal to 3 by 1, that is 3. What is sum of the roots of the equation which is to be formed? S equal to alpha minus 1 upon alpha plus 1 plus beta minus 1 upon beta plus 1. Take LCM, alpha plus 1 into beta plus 1. So equal to numerator alpha minus 1 into beta plus 1 plus beta minus 1 into alpha plus 1 whole divided by alpha plus 1 plus alpha plus 1 into beta plus 1 multiply alpha beta plus alpha minus beta minus 1 plus alpha beta plus beta minus alpha minus 1 whole divided by alpha beta plus alpha plus beta plus 1. Now alpha beta 2 alpha beta plus alpha minus alpha cancelled, minus beta plus beta cancelled, minus 1 minus 1 minus 2 whole divided by alpha beta plus beta plus 1. Alpha beta is 3, so 2 into 3. The denominator alpha beta is 3, alpha plus beta is 2. So 2 into 3 minus 2 whole divided by 3 plus 2 plus 1. That is 6 minus 2 by 6. That is 4 by 6. That is 2 by 3. So we know the value of S. S equal to 2 by 3. Then product alpha minus 1 upon alpha plus 1 into beta minus 1 by beta plus 1. That is the product of the two roots. That is alpha minus 1 into beta minus 1 divided by alpha plus 1 into beta plus 1. Multiply alpha beta minus beta plus 1. Denominator multiply alpha beta plus beta plus 1. That is alpha beta minus of alpha plus beta, taken minus common, plus 1. Denominator alpha beta plus beta plus 1. We know alpha beta and alpha plus beta. Substitute 3 minus 2 plus 1 divided by 3 plus 2 plus 1. That is 2 by 6. That is 1 by 3. So the value of P, product of the roots, is known. What is the required equation? X square minus Sx plus P equal to 0. That is x square minus 2 by 3 is the value of S and 1 by 3 is the value of P. So x square minus 2 by 3x plus 1 by 3 equal to 0. We don't want fractions. To avoid the fractions, multiply throughout by 3. So 3x square minus 2x plus 1 equal to 0. That is the required equation. We have finished the sum. Unit exercise 3, question number 16. If minus 4 is a root of the equation, if minus 4 is a root of the equation x square plus px minus 4 equal to 0, and if the equation x square plus px plus q equal to 0 has equal roots, find the values of p and q. Given minus 4 is a root of the equation x square plus vx minus 4 equal to 0. So x equal to minus 4 must satisfy this equation. That is minus 4 the whole square plus p into minus 4. Minus 4 must be equal to 0. That is 16 minus 4p minus 4 equal to 0. That is 12 minus 4p equal to 0. That is 4p equal to 12. That is p equal to 3. So we have got the value of p. Now we have to get the value of q. It is given the equation x square plus px plus q equal to 0 as equal roots. Therefore, the discriminant delta must be equal to 0. That is b squared minus 4ac must be equal to 0. That is p square minus 4 times 1 into q must be equal to 0. That is p square minus 4q must be equal to 0. But we have already got the value of p. Let us substitute p equal to 3. That is 3 square minus 4q equal to 0. That is 9 minus 4q equal to 0. That is 4q equal to 0. That is the value of q is 9 by 4. So P equal to 3, Q equal to 9 by 4. We have got the values of P and Q. Done. Unit exercise 3, sum number 17. Two farmers, Senthil and Ravi, cultivates 3 varieties of grains, namely rice, wheat and ragi. If the sale in rupees of 3 varieties of grains by both the farmers in the month of April is given by the matrix. Capital A equal to the matrix is given, and the May month sale in rupees is exactly twice as that of April month. The May month sale is exactly twice as that of April month. We have to find 2 subdivisions. What is the average sale of months April and May, and then if the sales continues to increase in the same way in successive months, what will be the sales in the month of August? So we are given the matrix capital A, which represents sale in April in rupees. Rice, wheat, ragi. The 2 farmers, the farmers are Senthil and Ravi. These are the amounts of sale of Senthil. Senthil sells 500 rupees of rice, 1000 rupees of wheat and 1500 rupees of ragi. Similarly for Ravi, Ravi sells 2500 rupees worth of rice, 1500 rupees worth of wheat and 500 rupees worth of ragi. Now let us do the first subdivision. What is May sale? It is exactly twice that of the April sale. So May sale is 2 times A. Multiply each number by 2. So 1000, 2000, 3000, 5000, 3000 and 1000. These are the sales for the month of May. The sale for May is twice the sale for April. Sale amount twice the sale amount. Now we have to find the average sales of April and May. We have April sale, we have got May sale. Just add the 2, divide by 2. So average sales for the months of April and May. We know April sales, we know May sales. April sales is A, May sales is 2A, add, divide by 2. So we have to add these 2 matrices and divide by 2. That is equal to 700, 1500, 2250, 3750, 2250 and 750. And this is A plus 2A divided by 2. The 2 matrices are added and divided by 2. That is 500 plus 1000, 1500 divided by 2, that is 700. 1000, 2000 added 3000 divided by 2, 1500. 1500, 3000 added 4000. Here 1500, 3000 added 4500 divided by 2, 2250. 5000 and 2500 added and divided by 2, we get 3750. 1500, 3000 total 4500 divided by 2, 2250. 500, 1000 total 1500 divided by 2, 750. So this matrix represents the average sale in the months of April and May. Second subdivision. If the sales continues to increase in the same manner, so for every month the sales is twice that of the previous month. For May we have 2A. For May we have 2A. For the month of May we have 2A. A is the sale for April. For May 2 times April. May 2 times 2A. For the month of May the sales is 2 times the sale for April. So it is 2A. For June it will be 2 times May. That is 2 times 2A. That is 4A. For July it will be 2 times that of June. That is 2 times 4A. That is 8A. For August it will be 2 times July. That is 2 times 8A. That is 16A. So for August the amount of sales will be 16A, where A is the sales for the month of April. So each element of the matrix A, is multiplied by 16, because sale for August is 16 times that of April. So 8,000, 16,000, 24,000, 40,000, 24,000, 8,000. That is the final answer. That is the sale for August. We have multiplied each element of that A matrix by the number 16. 16 into 500, that is 8,000. 16 into 1000, that is equal to 16,000, and so on. So this is the answer. Let me repeat. For May it is twice April. For June it is twice May. For July it is twice June. For August it is twice July. So for June it is 2 into 2A, 4A. For July 2 times June, that is 2 into 4A, 8A. For August 2 times July. July is 8A. 2 times 8A is 16A. We know the matrix A. Multiply the matrix A given in the question by 16, getting this result. So the problem is over. Unit exercise 3, sum number 18. If cos theta into the matrix cos theta sin theta minus sin theta cos theta plus sin theta into the matrix x minus cos theta x is equal to I2. That is unit matrix of order 2, 1 0 0 1. Then what is the value of x? The textbook problem here it is into, that must be corrected as plus. Now cos theta into this matrix. So we have to multiply each element of this matrix by cos theta, getting the matrix cos square theta sin theta cos theta minus sin theta cos square theta plus each element of this matrix, the second matrix, must be multiplied by sin theta, getting x into sin theta minus sin theta cos theta x sin theta, and that is given to be equal to 1 0 0 1. Now we have to add the two matrices. Cos square theta plus x sin theta, the corresponding elements must be added. Cos square theta plus x sin theta. Sin theta cos theta added with minus sin theta cos theta 0. Minus sin theta cos theta added with the sin theta cos theta 0. And cos square theta plus x sin theta. And that's equal to 1 0 0 1. It is given in the problem. The corresponding elements of the two matrices must be equal. So cos square theta plus x sin theta equal to 1. That is x sin theta equal to 1 minus cos square theta. 1 minus cos square theta is sin square theta, because sin square theta plus cos square theta equal to 1. So what is 1 minus cos square theta? Sin square theta. So x sin theta equal to sin square theta. So the value of x is sin square theta divided by sin theta. one sin theta gets cancelled. The answer is sin theta. So we have got the value of x as sin theta. Now I have got the answer by equating cos square theta plus x sin theta equal to 1. You can get the answer by equating cos square theta plus x sin theta equal to 1. You will get the same answer, x equal to sin theta. So the problem is over. Unit exercise 3, sum number 19. We are given matrix A, matrix B, matrix C, and BA equal to C squared is given. BA is equal to C squared. We have to find P and Q. Let us find BA. BA equal to B is 0 minus Q 1 0. A is P 0 0 2. 2 by 2 2 by 2. Now the number of columns of B equal to number of rows of A. So BA exists and BA will be a 2 by 2 matrix. First row OD first column 0 into P 0 minus Q into 0 0 total 0. 0 into 0 0 minus Q into 2 minus 2Q total minus 2Q. Now second row first column 1 into P 0 to 0 0 total P. 1 into 0 0 0 into 2 0 total 0. So we have obtained BA equal to 0 minus 2Q P 0. Now what is C squared? C into C. C is given in the problem. 2 minus 2 2 2, that matrix. So 2 minus 2 2 2 into 2 minus 2 2 2. 2 by 2 matrix, 2 by 2 matrix, they can be multiplied. The result will be a 2 by 2 matrix. 2 into 2 minus 2 into 2 total 0. 2 into minus 2 minus 4 minus 2 into 2 minus 4 total minus 8. 2 into 2 4 2 into 2 4 total 8. Second row second column 2 into minus 2 minus 4 2 into 2 4 total 0. So we have got C squared. What is given in the problem? BA equal to C squared. We have calculated BA. We have calculated C squared. So BA equal to C squared. In other words, 0 minus 2Q P0 is equal to 0 minus 8 80. That is BA is written here, C squared is written here. The two matrices are given to be equal. The corresponding elements must be equal. So P equal to 8 minus 2Q equal to minus 8. That is Q equal to minus 8 divided by minus 2, that is 4. So the values of P and Q are P equal to 8 and Q equal to 4. Unit exercise 3, sum number 20. We are given matrix A, matrix B, matrix C, and the relation CD minus AB equal to the null matrix. We have to find the matrix D. So let us first find AB. A we know, B we know. So find AB. Usual multiplication of matrices, we get 18, 9, 64, 37. Now CD minus AB equal to null matrix. C is given 3, 6, 1, 1 into D we have to find, minus AB we have calculated 18, 9, 64, 37 equal to null matrix. So the matrix D we have to find. Now D, the order of D matrix can only be 2 by 2. Then only we can find CD, and this matrix 2 by 2 matrix can be subtracted from CD. So D must be a 2 by 2 matrix. Let us assume that 2 by 2 matrix as P, Q, R, S. The elements are assumed to be P, Q, R, S. So multiply the two matrices. 3P plus 6R. 3Q plus 6S. First row over. 1P plus 1R. That is P plus R. 1Q plus 1S. That is Q plus S. We have multiplied the two matrices. And minus of this matrix is equal to null matrix. You take to the other side, that is equal to 18, 9, 64, 37. The corresponding elements of the two matrices must be equal. So 3p plus 6r equal to 80. In other words, p plus 2r equal to 6 divided throughout by 3. 3q plus 6s equal to 9. That is q plus 2s equal to 3 divided throughout by 3. P plus r equal to 64. Equation 3. Q plus s equal to 37. So we have got 4 equations. We have to find the values of P, Q, R and S. P plus 2r equal to 6. Q plus 2s equal to 3. P plus r equal to 64. Q plus s equal to 37. We have got 4 equations, linear equations in P, Q, R, S. We have to find the values of P, Q, R and S. First equation, P plus 2r equal to 6. The third equation, P plus r equal to 64. Subtract. P gets cancelled. R equal to minus 58. So we have got the value of R. Now the second equation, Q plus S equal to 3. The fourth equation, Q plus S equal to 37. Subtract. Q gets cancelled. S equal to minus 34. So R known, S known. Now P plus R equal to 64. Third equation. The value of R is minus 58. So substitute. P minus 58 equal to 64. That is P equal to 64 plus 58. That is P equal to 122. Now we have Q plus S equal to 37. Fourth equation. We know the value of S. Q minus 34 equal to 37. That is Q equal to 37 plus 34. That is 71. Q equal to 71. So the values of P, Q, R, S are known. So we can write down the matrix D. P, Q, R, S. That is 122, 71, minus 58, minus 34. That's all.